Hey guys, welcome back in. Mr. Marone here. So we are in day 2 of lesson 8.1, where we're talking right triangles and looking at side lengths of right triangles. We looked at Pythagorean theorem last, and that's like kind of our home base. And now we're going to take a look at what we can do to make our life easier, so we don't have to do Pythagorean theorem every time. And there are actually two sets of special right triangles, meaning given specific angle measures, they have different properties, and it actually speeds up the process. So the first one we're going to look at is the 45-45-90 right triangle. So if I've got an example here, this is also an isosceles triangle since my two legs are the same measure. And if we look to solve for x here in this first problem, I've got 6 squared plus 6 squared equals x squared. And if I work my way through this, I have 36 plus 36 equals x squared, and I have 72 equals x squared. I'm now going to have to do simplifying radicals here, and simplifying 72 is going to give me radical 36 and radical 2, and radical 36 just gives me 6, so x in this case equals 6 radical 2. So if we continue to do this, if I gave you a 45-45-90 where the two sides were 10, or the two sides were 12, or the two sides were 4, you'd end up with the same thing over and over and over again. If I've got a 45-45-90 right triangle, the two legs are going to have the same side measure, and the hypotenuse is always going to be whatever the side measure is times radical 2. Just like we got here, my two side lengths were 6, and my hypotenuse was 6 radical 2. So the beautiful thing is you don't ever have to even do Pythagorean theorem with this type of setup. So when I've got a 45-45-90 right triangle, the two sides are the same measure, and the hypotenuse is always going to be radical 2 times whatever the side length is. So it gives us a real shortcut here. So if you're looking closely in this little picture down here, the two side lengths are going to always have the same measure. In this case, we made it 1. And then our hypotenuse will be 1 times radical 2, or whatever the number is, times radical 2. So our shortcut is listed here is when you start with the short side, all you have to do to get the hypotenuse is multiply by radical 2. Our goal in all of these is to start with the short side, or get that side first. If we're going to a bigger side, if we need to go to the hypotenuse, we're going to multiply. If we're going back to the short side, we're going to have to divide. So let's take a look at a couple examples here. So I've got 3 examples for you. In this first one, they gave us the hypotenuse as 8 radical 2. We don't know what we have here, and if we really wanted to do the work of it, we could do x squared plus x squared equals 8 radical 2 squared, and we could work our way through it. But if we know that in every 45-45-90 right triangle, I've got my two legs and my hypotenuse, as you see that I wrote in there. In this setup, in all 45-45-90 right triangles, our hypotenuse is always equal to the leg times radical 2. That's what we saw back in our formula on that previous page. So if I use this formula in all of these, or starting with this one, my hypotenuse right there is 8 radical 2. And that equals my leg, in this case x, times radical 2. So if I wanted to solve this out, I'm going to divide both sides by radical 2. And I'm left with 8 equals x. So my two legs are going to be equal to 8. Now, whenever you're given a setup like this, like you see here, if I gave you the number 10 radical 2, now that you know 45-45-90s, it should be a quick thing. Just divide by radical 2 and move on. You have 8 for that one. If I've got a setup like my second or my third one, we're going to use the same process. My hypotenuse is radical 8, so I'm going to do radical 8, and that equals x, my leg, times radical 2. So I'm going to once again divide both sides by radical 2 to get rid of my radical 2 attached to the x. And whenever you're dividing a radical by a radical, you can actually put it under a single radical. And 8 divided by 2 is going to give me a radical 4, which in this case gives me 2 for my two legs. So just because I've got this radical divided by radical, you can put it under a single radical with a fraction, and then you just simplify inside. Okay. The hardest of the three, really the most tricky of all three of these types, are this last one. So once again, my hypotenuse is 8. So I've got 8, and that equals radical 2 times x. I'm going to divide both sides by radical 2. I'm not sure if you're noticing a pattern here. And if you think back to our algebra rules or pre-algebra, you're never allowed to have a radical in the bottom of a fraction. Okay, we can't have a 0 and we can't have a radical. So what we can do, I've got 8 over radical 2 equals x, is you can end up multiplying this. I like to call it math black magic, but you can multiply this whole thing by 1. I can multiply both sides by 1. And you're going to be saying, Mr. Rohn, that makes no sense. How is that helping us? Well, on the right-hand side, it stays x, but on the left-hand side, any number divided by itself is 1. So I can actually write this as 8 over radical 2, and I can multiply the top and the bottom by radical 2, because that's just 1. Radical 2 divided by radical 2 is going to give me 1. And what that does for me, if I multiply these fractions, is I have 8 radical 2 over radical 2 times 2, which is going to give me 8 radical 2 over radical 4. And we saw over here that radical 4 is just 2. So I've got 8 radical 2 over 2. This is called rationalizing the denominator. Okay, so this process is something you can always use in this scenario, and you're going to have to use it in this scenario. And it allows you to get rid of the radical on the bottom of the fraction. So I've multiplied the top and bottom by radical 2, and just doing algebra, the thing that you did all last year, I ended up with a radical 4 on the bottom or just a 2 on the bottom. And then I can simplify 8 divided by 2, and that gives me that x equals 4 radical 2. Okay? This last one is tricky, so I hope that you understand a little bit. The goal is for you to come into class tomorrow and practice this. And I hope that you bring these questions in with you, specifically on these last ones. So just to recap, if I've got a 45, 45, 90 right triangle, 45, 45, 90, I've got my leg, and I've got my hypotenuse. And my hypotenuse is always equal to our leg times radical 2. And that's our one formula. That's it. No matter what you're given, no matter what picture you're given, no matter what numbers you're given, it's always going to be this right here. So this is kind of your massive takeaway that you're going to want to write down. And that's going to be our one rule. That's all we have for 45, 45, 90 right triangles. Make sure to bring in any questions you have into class tomorrow, and I will see you all then. Have a great night. Bye, guys.